The sound that defined the German infantry squad in World War II was the terrifying, ripping buzzsaw of the MG-42 machine gun. Firing at an astonishing 1,200 to 2,500 rounds per minute, it was a masterpiece of lethal engineering, capable of spewing a wall of lead that could cut down entire platoons in seconds. German doctrine revolved around this weapon. The rifleman existed primarily to support and protect the machine gunner, the true source of the squad's firepower. But this incredible rate of fire concealed a critical, almost invisible logistical flaw, a flaw rooted in the very chain that fed the beast, the machine gun belt. The German system primarily relied on non-disintegrating metallic belts, Gert 3441, or in some cases, drum magazines. These belts were models of German efficiency and precision. Typically holding 50 rounds, they were designed to be linked together to form longer belts, often 250 rounds long for sustained fire. After firing, the empty metal belt remained intact, emerging from the side of the gun. German doctrine demanded meticulous discipline. These expensive, reusable belts had to be collected, reloaded, and carefully maintained. This philosophy reflected a mindset of resource conservation and engineering precision. Every component was valuable and designed to last. However, this theoretical efficiency created practical nightmares on the battlefield. A machine gunner under heavy fire had to stop shooting when his 250-round belt ran dry. Reloading involved either attaching a new 50-round starter tab or, more awkwardly, having an assistant gunner feed in a completely new, heavy belt. This pause, lasting 10 to 15 seconds, was a potentially fatal window of silence during which enemy troops could advance or counterattack. Furthermore, the need to collect the empty, cumbersome metal belts added another burden to soldiers already overloaded with ammunition and equipment. In the chaos of a retreat or a rapid advance, these belts were often lost or damaged, creating logistical headaches far from the front line. The elegant German system designed for order and reuse was inherently interruptible. The American military faced a similar challenge but approached it from a fundamentally different industrial philosophy. The workhorse American machine gun, the Browning M1919 .30 caliber, was a slower-firing, air-cooled weapon, robust and reliable, but lacking the sheer terror-inducing rate of fire of the MG-42. American doctrine emphasized sustained, suppressive fire as a cornerstone of infantry tactics, both in attack and defense. They needed a way for the M1919 to keep firing continuously, without the awkward pauses dictated by fixed-length belts. The solution was not a revolutionary new gun design or a more powerful cartridge. It was an almost invisibly simple innovation in the ammunition feed system, the M1 disintegrating metallic link belt. Instead of a continuous metal strip, the American system used individual steel links, each holding a single cartridge. As the round was chambered and fired, the empty link was ejected along with the spent cartridge case, effectively disintegrating the belt as it passed through the gun. To a German engineer obsessed with precision and resource management, this system would have looked like pure, unadulterated waste. Why design a system that intentionally throws away perfectly good steel links after a single use? It seemed inefficient, crude, and logistically extravagant. It represented the American philosophy of disposable abundance over sustainable craftsmanship. But this perceived weakness, this willingness to discard the links, was the very core of an unstoppable tactical advantage. The simple, wasteful, disintegrating belt was about to give the American infantryman the one thing the German system could never provide: truly continuous, uninterrupted firepower. The genius of the American M1 disintegrating link belt lay in its radical simplicity and its embrace of expendability. Each .30 caliber cartridge was held by a small, precisely stamped steel link. These individual links were designed to snap together, forming a flexible belt of any desired length. Inside the Browning M1919 machine gun, the mechanism was straightforward. As the bolt cycled, it stripped a round from the link, chambered it, and fired it. The critical innovation happened after firing. The mechanism was designed to eject not only the spent brass cartridge case, but also the now empty steel link. The belt literally fell apart, link by link, as it was consumed by the gun. Contrast this with the German Gert 34 or Gert 41 belt used by the MG-42. This was a continuous metal band, often made of articulated steel segments, designed to remain intact after firing. While this allowed for easy reloading of the belt itself, a task usually done far from the front line, it imposed rigid limitations on the battlefield. The gunner was always constrained by the finite length of the belt currently loaded, typically 50 rounds, often linked into a 250-round segment. When that belt ran dry, the gun fell silent. The American disintegrating system eliminated this constraint entirely. The most significant tactical advantage was the potential for virtually uninterrupted fire. Because the links were individual units, new belts could be seamlessly connected to the tail end of the belt currently feeding into the gun. A skilled assistant gunner could snap the starter tab of a fresh 100 or 250 round belt onto the last link of the belt being fired, creating a continuous chain of ammunition. As long as ammunition was available, the Browning M1919 could keep firing, delivering sustained suppressive fire without the predictable, dangerous pauses inherent in the German system. This capability fundamentally changed the rhythm of infantry combat. German machine gunners knew they had a brief, predictable window, the 10 to 15 seconds required to reload a non-disintegrating belt, during which Allied troops could safely advance or maneuver. American machine gun crews using the M1 links could maintain fire almost indefinitely, pinning down enemy positions for minutes at a time, allowing their own riflemen to flank and assault. That brief pause, the window of death exploited by attacking infantry, was effectively eliminated by the simple act of discarding the empty link. Furthermore, the disintegrating belt simplified the role of the assistant gunner. With the German system, the assistant was often burdened with managing the cumbersome empty belt as it snaked out of the gun, preventing jams and preparing it for collection. With the American system, the assistant's primary focus could remain on feeding new ammunition belts and scanning for targets. The ejected links simply fell away, becoming insignificant battlefield debris. This freed up crucial seconds and mental bandwidth for the gun crew, improving their situational awareness and overall effectiveness. The German engineers, observing captured American equipment, initially dismissed the disintegrating link as wasteful and logistically inefficient. They calculated the cost of the discarded steel and saw only unnecessary expenditure. They failed to grasp the strategic value of time bought by that discarded link. The American philosophy correctly identified that the cost of a few seconds of silence during a firefight, seconds that could cost soldiers' lives or halt an advance, was infinitely higher than the cost of a small piece of stamped steel. The M1 link wasn't waste. It was an investment in continuous, overwhelming firepower, purchased at the negligible price of expendability. The logic of disintegration was the logic of sustained combat dominance. The contrast between the German non-disintegrating belt and the American M1 disintegrating link extended far beyond the immediate tactical advantages on the battlefield. It reflected a fundamental divergence in industrial philosophy and logistical design. The decision to embrace expendability was not merely a feature of the ammunition feed, it was a core principle of the entire American war economy. German industry, operating under severe resource constraints and a deeply ingrained tradition of craftsmanship, viewed every component as precious. The reusable Gert 34 belt was a product of this mindset. It required precise manufacturing, careful maintenance, and a complex reverse logistics chain to collect, clean, repair, and reload the empty belts. This system, while efficient in conserving raw materials, created significant burdens. Specialized machinery was needed for reloading. Dedicated personnel were required for maintenance. And crucially, the system relied on the successful recovery of belts from chaotic battlefields, a task that often proved impossible, leading to shortages despite the theoretical reusability. The American approach, powered by vast industrial capacity and abundant raw materials, particularly steel, prioritized speed and throughput above all else. The M1 disintegrating link was designed from the outset for mass production and disposability. Each link was a simple piece of stamped steel, requiring minimal machining and quality control compared to the articulated German belts. Factories could churn out millions of these links using the same high-speed stamping presses employed in the automotive industry. The cost per link was negligible, fractions of a cent. This industrial logic permeated the entire ammunition supply chain. American ammunition arrived at the front lines pre-linked into belts, often sealed in disposable metal or cardboard containers. There was no need for specialized reloading equipment near the front. There was no requirement for soldiers to collect empty links under fire. The logistical burden was entirely focused on pushing new, ready-to-use ammunition forward, not on managing the return flow of used components. This wasteful approach horrified German logisticians who meticulously tracked every reusable casing and belt. They saw the fields littered with discarded American links as evidence of undisciplined profligacy. What they failed to recognize was that this waste was the price of speed and simplicity. By eliminating the need for reverse logistics and complex reloading procedures, the American system dramatically reduced the manpower and time required to keep machine guns fed. The focus shifted entirely from conservation to consumption. Furthermore, the simplicity of the M1 link design made it inherently more reliable in harsh conditions. The articulated joints and springs of the German belts were vulnerable to mud, sand, and ice, leading to feeding problems and jams, particularly catastrophic for the high-speed MG42. The simple, robust design of the individual M1 links, combined with the powerful action of the Browning machine gun, proved far less susceptible to environmental fouling. The system was designed to function even when dirty, abused, and neglected, precisely the conditions encountered in sustained combat. The American willingness to discard the link was not a sign of industrial carelessness. It was a calculated strategic decision. It recognized that the true bottleneck in modern warfare was not the availability of raw steel, but the speed and reliability of delivering firepower to the critical point on the battlefield. The disintegrating belt simplified every step of that process, from manufacturing to deployment to sustained use. The industrial logic of waste was, in fact, the industrial logic of uninterrupted combat effectiveness. The difference between the two belt systems translated directly into the brutal calculus of fire superiority on the front lines. American infantry units quickly learned to exploit the continuous firing capability of their Browning M1919 machine guns, turning suppressive fire from a temporary measure into a sustained, overwhelming force. Consider a typical infantry assault scenario in the hedgerows of Normandy or the forests of the Ardennes. An American squad needs to advance across an open area covered by a German MG-42 position. Under German doctrine, the MG-42 would unleash a devastating burst, pinning the attackers down. But the gunner knew he had a finite window, perhaps 10 seconds of continuous fire before needing to reload his 250-round belt segment. Experienced American GIs learned to anticipate this pause. They would wait for the distinctive high-pitched roar of the MG-42 to momentarily cease, then use those precious 10-15 seconds of relative silence to dash forward, close the distance, or bring flanking fire to bear. The American M1919, fed by its disintegrating links, offered no such predictable respite. When an American machine gun team opened fire to support an assault, they could maintain that fire almost indefinitely. As one belt ran low, the assistant gunner would seamlessly link the next belt, keeping the gun in action. The sound wasn't the terrifying crescendo and sudden silence of the MG-42. It was a steady, relentless hammering, thump, 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 that simply did not stop. This continuous stream of .30 caliber rounds created a beaten zone that German defenders could not safely traverse or even peek over. It provided the crucial, unbroken covering fire needed for American riflemen to maneuver and assault enemy positions effectively. Defensively, the advantage was equally significant. During German counterattacks, particularly the massed infantry assaults common on the Eastern Front and occasionally seen in the West, the ability to maintain continuous fire was critical. A German MG-42 team might inflict horrific casualties during their initial bursts, but the forced reloading pauses created vulnerabilities that attacking waves could exploit. An American M1919 position, supplied with adequate ammunition boxes, could maintain a constant wall of lead, breaking up attack formations and channeling enemy movement into pre-planned kill zones. The disintegrating belt effectively transformed the M1919 from a standard machine gun into a continuously operating fire support base. German soldiers, accustomed to the rhythm of their own weapons, were often psychologically unnerved by the seemingly endless fire projected by American machine gun positions. Captured German reports frequently mentioned the demoralizing effect of facing American machine guns that never seemed to run out of ammunition. This perception, while not literally true, reflected the tactical reality created by the disintegrating belt. The pauses were so short and unpredictable that, from the receiving end, the fire felt unbroken. Intelligence analysis by the Wehrmacht struggled to pinpoint the source of this advantage. They knew the Browning M1919 fired slower than the MG-42. They knew the .30 caliber round was ballistically similar to their own 7.99mm Mauser. Some reports speculated about superior American barrel cooling technology or even secret modifications to the guns themselves. The truth, that the advantage lay in the cheap, disposable links connecting the bullets, was so counterintuitive to the German engineering mindset that it was often overlooked or dismissed. They were searching for a complex technological superiority, failing to recognize the profound tactical impact of a simple logistical innovation. The sound of unbroken American machine gun fire was the sound of a fundamentally different industrial philosophy grinding down the German war machine. The seemingly minor difference in machine gun belt design scaled up to create a massive logistical disparity between the two armies. The German commitment to the non-disintegrating belt, while rooted in a sound philosophy of resource conservation, imposed a heavy and often invisible tax on their entire supply and maintenance system, a tax that the American disposable approach completely avoided. Consider the journey of a German machine gun belt after it had been fired. The empty, articulated metal strip, often several feet long and weighing several pounds, became another piece of battlefield clutter that, according to doctrine, had to be recovered. This task fell upon the already overburdened infantry squads. Collecting these belts under fire was dangerous and often impossible. Belts dropped in mud, lost in shell craters, or simply abandoned during hasty retreats represented a constant drain on the available supply. Even when recovered, the belts required significant processing. They had to be transported back from the front lines, cleaned of mud and debris, a critical step as fouling could cause jams, inspected for damaged links, repaired if necessary, and finally reloaded using specialized belt loading machines often located far behind the lines. This entire reverse logistics chain consumed manpower, transport capacity, and time, all critical resources in a losing war. Why didn't the Germans simply copy the American disintegrating link? The answer lies partly in industrial inertia and partly in resource scarcity. German industry was already geared towards producing the complex Gert 3441 belts. Shifting production to a completely new system, mid-war, would have required significant retooling and disruption at a time when every rifle and shell was desperately needed. More fundamentally, the American system was predicated on steel abundance. The US could afford to treat millions of steel links as disposable. Germany, facing critical shortages of high-quality steel due to Allied bombing and dwindling access to raw materials, could not justify a system that intentionally discarded metal after a single use. Their philosophy of conservation was born not just of tradition, but of grim necessity. They were trapped in a cycle where their need to save resources forced them into a logistical system that ultimately cost them more in battlefield effectiveness. The American system, by contrast, was ruthlessly efficient precisely because it embraced waste. Ammunition arrived pre-belted. Once fired, the links were forgotten. The logistical chain focused solely on pushing more ammunition forward. There was no need for belt recovery teams, specialized cleaning facilities, or complex reloading machines near the front. The burden on the supply system was halved, and the burden on the frontline soldier was significantly reduced. The American GI didn't have to worry about managing empty belts. He only had to worry about getting the next full can of ammunition to the gunner. German intelligence continued to misunderstand the source of American machine gun superiority. Captured Allied equipment reports focused on the Browning M1919's mechanism, its cooling system, or the quality of its barrel steel. They often noted the primitive and wasteful nature of the disintegrating links, but failed to connect this design choice to the observed operational tempo of American units. They saw the discarded links as a sign of weakness, poor discipline, and resource management, rather than the key enabler of sustained, uninterrupted fire. This failure to grasp the logistical brilliance disguised as waste prevented them from adapting their own tactics or appreciating the true nature of the American firepower advantage. The German pursuit of the perfect, reusable belt had created a logistical nightmare that slowly bled their combat effectiveness, while the American acceptance of the disposable link streamlined their path to fire superiority. The simple disintegrating link became an invisible yet decisive factor in the grinding attritional battles that defined the later stages of World War II, particularly during the Allied push through France, the Hürtgen Forest Campaign, and the Battle of the Bulge. While historians often focus on tank numbers or air superiority, the mundane reality of machine gun ammunition feed systems had a profound impact on the infantryman's ability to sustain combat. In the brutal, close-quarters fighting of the Hürtgen Forest, where visibility was often limited to a few yards and engagements were sudden and vicious, the ability to maintain continuous suppressive fire was paramount. German units, often well-entrenched and masters of defensive tactics, relied heavily on their MG-42s to break up American assaults. However, the relentless dampness, mud, and debris of the forest floor frequently fouled the complex German non-disintegrating belts. Reloading under intense fire, exacerbated by the need to manage both the incoming full belt and the outgoing empty one, often resulted in critical delays or weapon jams at the worst possible moments. American units, employing their Browning M1919s fed by the simple M1 links, faced fewer of these environmental challenges. The links were less prone to jamming from mud, and the lack of an empty belt to manage simplified operation in confined spaces like foxholes or dense undergrowth. More importantly, the ability to link belts together allowed American gunners to lay down minutes of continuous fire, creating the sustained pressure needed to cover advances or repel counterattacks. German veterans of the Hürtgen campaign often described the unnerving persistence of American machine gun fire, a seemingly endless stream of bullets that denied them the brief reloading pauses they relied upon to maneuver. During the Battle of the Bulge, the extreme cold added another layer of difficulty. Lubricants thickened, metal contracted, and handling stiff, frozen metal belts became a nightmare for German gun crews wearing thick gloves. While the Browning M1919 was not immune to cold weather issues, its simpler feed mechanism and the individual nature of the disintegrating links proved inherently more robust in sub-zero temperatures. American units, often outnumbered and fighting desperately to hold defensive positions, were able to maintain a higher rate of operational machine gun fire, contributing significantly to slowing the German advance. The critical factor was often not the theoretical rate of fire, but the actual minutes per hour that the gun could reliably function under duress. The disintegrating link system consistently delivered more firing time. The strategic effect was cumulative. Every time a German machine gun fell silent during a reload, it created a small tactical opportunity for the Allies. Every time an American machine gun continued firing, it denied such an opportunity to the Germans. Multiplied across thousands of engagements along hundreds of miles of front, these small increments of time added up to a significant attritional advantage. The American system, by prioritizing continuous operation and simplicity over resource conservation, inflicted a higher rate of sustained casualties and maintained suppressive fire more effectively. Furthermore, the logistical ease of the disintegrating link system allowed American forces to sustain higher ammunition expenditures. Because the supply chain was simpler, only delivering full belts, not managing empty ones, American units could be supplied with more ammunition, more quickly. This translated into a greater volume of fire on the battlefield. German units, constrained by the complexities of their belt system and dwindling resources, were often forced to conserve ammunition and fire in shorter, more controlled bursts. The Americans, backed by their industrial might and a feed system designed for consumption, could afford to be profligate with their bullets, using sheer volume of fire to compensate for any perceived lack in the Browning's rate of fire compared to the MG42. The simple, disposable link was enabling a strategy of overwhelming, sustained firepower that the German system simply could not match. The war ended, leaving behind fields littered not just with shell casings, but with millions upon millions of small, discarded steel links, the almost invisible evidence of a profound strategic victory won through industrial philosophy. The story of the disintegrating machine gun belt is the ultimate parable of complexity versus consumption in modern warfare. The German military machine, built upon a foundation of engineering excellence and resource scarcity, created masterpieces like the MG42. Their non-disintegrating belt system was a logical extension of this philosophy, precise, durable, and designed for reuse. It was the embodiment of quality over quantity. But this commitment to quality imposed a fatal tax on speed, logistics, and battlefield reliability. The need to reload, the vulnerability to fouling, and the burden of reverse logistics created moments of silence, brief but deadly pauses in firepower that the Allies learned to exploit relentlessly. The American system, embodied by the simple M1 disintegrating link, embraced the opposite philosophy: quantity and continuity over conservation. Designed for mass production using automotive stamping techniques and fueled by America's seemingly limitless industrial capacity, the link was treated as a disposable commodity. Its genius lay not in its intrinsic quality, but in its simplicity and expendability. By eliminating the need for reloading pauses and the burden of collecting empty belts, the disintegrating link allowed American machine guns to achieve unprecedented levels of sustained fire. It transformed the Browning M1919 from a conventional machine gun into a continuously operating engine of suppression. The post-war analysis confirmed what frontline soldiers already knew. The seemingly minor design choice of using disintegrating links had a measurable impact on battlefield outcomes. American units consistently demonstrated superior fire superiority in defensive engagements, and provided more effective covering fire during assaults, directly attributable to the ability to maintain uninterrupted machine gun operation. The German focus on the MG42's high rate of fire blinded them to the strategic advantage gained by the continuity of the American system. A gun firing at 600 rounds per minute without stopping is often more effective than a gun firing at 1,200 rounds per minute with predictable 15-second pauses. The legacy of the disintegrating link extends far beyond World War II. It became the global standard for belt-fed automatic weapons precisely because it solved the fundamental problem of continuous fire in the simplest, most logistically efficient manner. The German masterpiece belt system, while elegant, became a footnote in ordnance history. The final verdict is inescapable. In the brutal mathematics of industrial warfare, the system that prioritizes continuous operation and logistical simplicity will always defeat the system that prioritizes resource conservation at the cost of battlefield tempo. The German army paid the ultimate price for those few seconds of silence imposed by their perfectly engineered, reusable belt. The American victory was built, in part, on the humble, disposable steel link, a testament to the fact that sometimes the willingness to embrace waste is the most efficient path to overwhelming firepower.